Alright, so now we're going to look at finding the normal distribution values and percents when it's not the rule of thumb case. And for this class, we will be using the table, and you have to use the table that's provided in the book, the table that's provided in this set of notes, which is the exact same table. If you go to the formula sheets, alright, this is the formula sheet with everything on it. It's way at the bottom because it's chapter 6. But the Math 113 formula sheet with everything in it, alright, it's the table that we give you there. Alright, so this is the standard normal table, and then there's we're going to use this formula, the z-score formula at the bottom. Alright, so that's what we're using for this section, and you have to use this table. There is ways to do it, other ways to do it, other tables and calculators, but you can't do that. You have to use the standard normal curve because that is what the WebAssign is based on. The WebAssign, all of those numbers are based on the table, this particular table. The homework, so the homework is based on that. The quizzes, I use this table. And the exam, I use this table. So if you don't use this table and you use something else, your numbers could be significantly off because of rounding errors, alright, rounding differences. So you have to use this table. So you must use this table. The one given here in the notes, the one given in the book, the one that's on the formula sheet. Alright, so what we do is, what's happened is they've organized a standard normal curve. And what you have to do is you have to convert to the standard normal curve because all areas are related the same way, right? Because 65% of the area is always one standard deviation away. Or the same, again, so it's the same percentages every single time. And so what they do is, in order to, they set up what this is sort of a basic curve, right, which everything will convert to this. They make the basic curve where the average is at 0, so average is at 0 on my curve, and 1 is 1 standard deviation away. So this represents 1 standard deviation away, this is 2 standard deviations away, this is 3 standard deviations away. Right. Half of the area is above, so again this would represent 50%, and half of the percent is below, this is 50% from my mean. Right, and 1 standard deviation away would represent 68%, and so on. And so what this allows us to do, this allows us to look at deviations that aren't necessarily exactly 1. So what the table is the z-score represents the deviation. And so what we do is we have to convert it to this standard normal curve. And to do that, you have to use the formula to convert. So we convert all normals to the standard so that we can use the table. Which the conversion is, we take z, we take our x value given minus the mean given over the standard deviation, and that will give us our z-score, the z number. And what the z number represents, it does represent a standard normal deviation. So a z of 1 would represent 1 standard deviation. A z of 1.2 represents 1.2 standard deviations above the mean because it's positive. And a z-score of negative 1.2 would mean it's negative 1.2, so that would be below. Below is always the negative values. Alright, and so we get the negative values over here, the positive values over there. Alright, and so now we can look at any deviation from our mean. So just so that you know, when a z-score is negative, that means it's below the mean when our z is negative. When our z-score is positive, that means we land above the mean. Means our score is above the mean. I'm deviate above the mean. Alright, and so that's what it means. Alright, so standard, and so this is standard. So standard means we set the standard curve so that we could set up a table. So we go look at the table, and so basically what we do is we have to convert to this table. Alright, so 1 standard deviation means it's one unit above the mean, and then the way it's read, we'll go over in a second how the table's read, but that's where the table is set up. Alright, and you must use this table for homework, quizzes, and tests. Alright, so to sort of how to read the table and how to use the table to find your percents. Alright, so how to read the table. Alright, the table is set up that the z-score represents the percent above that. So it's a percentile. That's what it means. So this z-score represents this area. So this is the percentile. Alright, so it's the percent of scores below that value. Alright, so that's what this would represent. So if you get a z-value of 1.2, so z-value comes out 1.2, which means I'm above the mean, right? So that's the picture that we have drawn. So it means it's above the mean. And so this area would represent, this is the percent we get from the table. This is the table percent. The table percent represents the percentage that z-score is above. All of my scores land below it. Alright, so when I go look at the table, so this is the table, so there's the z-score, I go look at the z-score here, so there's the z-score of 1.2. It represents the 88% of the scores that it is above. It's a percentile. And so if we went to draw the picture, alright, my mean is at 0 on my standard Nova curve, my z-score is 1.2, and that really does represent 1.2 standard units above. And so this would represent 88.49%. That's what that represents. So 88.49% of the scores are less than 1.2 standard deviations above the mean. Right? That's what that represents. All right, that's the area below that z-score, or percent below. I keep saying area because I'm used to doing this in calculus, and we talked about it in terms of area. All right, so this is the percent below that z-score. Alright, find the percentage of z-values below the z-score of negative. So z-score of negative 1.9, which means it should be less than the mean. And so if we're looking at the picture, alright, the mean is at 0, so this would be down here, negative 1.9. And so this table would represent that percent. That's the percent that comes from the table. Alright, so I go look at the table. There's the z-score, negative 1.9. There's the percent. And so again, this percent is 2.87%, meaning all of the z-values below negative 1.9 represent 2.8% of the data set. That's what that represents. Alright, 2.8% below. So that's reading the table. The table is the percent below whatever my z-score I'm given. So what if I want to find above or between? Well, then it gets a little harder if I want to find above or between. So that's exactly reading from the table. That's what the table gives me. It gives me the percent below the z-score. So what if I want to find stuff above it? Alright, so what if I'm looking for the percent above my score? So this would be above the z-score. Alright, well, we want to find this percent. Alright, well, it's a little harder. It's not a lot harder, because I know the total area is 100%. The percent below is the table area, the table percent. I keep saying area. And so if I want to find the area above, which means to the right of the z-score, I take my 100%, subtract away the table percent at that z-score, and that will give me the percent to the right. Alright, so you do have to do a subtraction in this case, because the table gives me the percent below. Alright, so if I want to find the percentage of z-scores to the right of 1.6, so again, I'm going to draw the picture. So there's my z means 0, so 1.6 is above it, because it's positive, so my 1.6 lands here. It's 1.6 deviations above. And I want to find this percentage. What's the percent that lands above that, to the right? So I'm looking for this percent. Well, the table gives me this percent. So I look up my table value, I'm going to use my highlighter to find my table value. Alright, so this is the value my table gives me. So I look up my 1.6 on my table, so that puts me here. And so that means 94.52% lands below that. And again, just kind of being aware of what you're looking for and what you're asked to find, it should make sense that's not your answer. Very little should be above 1.6. 1.6 is almost 2 standard deviations. So 2 would be 2 standard deviations. And so remember, very few values land above that. Right? Very few values. So it should make sense that the 94 is not what we're looking for. We want to find the area that we're looking for where you take 100% minus the table value, and that will leave me with the percent that I'm asked to find. Alright, so you take 100% minus the 95.52 found in the table, and so that means this area above to the right is 4.48%. So 4.48% of the values land above a score of 1.6, a z-value of 1.6. Alright, let's look at another example. So again, above a negative, so my z-value is -2, so it means I should be below the mean. So again, just understanding what's going on, I'm going to draw the picture. Alright, so there's my 0. So -2 should be what, and again, that represents a 2 deviation. And I want to find the values above. So I'm looking for this area. So it should be the vast majority. It should be a bigger number, almost 100%. Alright. The table gives me the values below. So when I look up the table value, it's going to give me that area there. And so when I look up my -2, that's the table area. So this value here is 2.28, which again, that should make sense. That's not the answer. The answer should be much bigger than that. Most of the values land above 2 standard deviations away from the mean. Alright, and so what we do is, well, in order to find the percent I want, if I'm looking for above, which means to the right, I have to take 100% minus the percent given to me in the table, which is 2.28. And what's left over is the percent I'm looking for, which again should be the majority of it, and it is. 97.72% of the scores will land above -0.2. Alright, -0.2, which again, above subtracting 2 standard deviations. That's what that means. Right, the hard case. Bounded areas, meaning areas between 2 scores. Alright, so we've got a score 1 and a score 2. So we've got 2 score values, 2 z-values. Alright, this is the harder case. Alright, what you have to do is, well, remember what the table gives me. The table gives me the area less than it. And so if I'm looking up the table value for this, alright, that will give me the area here. Alright, less than the, so this would be the percent less than the first z-score. And then I look up a second table value and it'll give me this region here. So this is the percent less than the second z-score. And so what we have to do is, well, if you think about it that in terms of if I'm shading in my area. So if I found my first area, which would be all of this, and then my second area, which would be this little tail here. In order to find the blue area that I want, I take the big area, which is the first z-scores area, subtract away the little area, which is the second z-score area. And so that's what we're going to do. Alright, so you're going to take the percent at the z-score 1 minus the percent at the z-score 2. And this percent means coming from the table. Alright, so again, you take the z-score 1, you're going to find its area, which is all of this area here, and then subtract the z-score 2, which is this area here, this blank area here. The difference will leave me with that blue area. Alright, so that's what the difference will leave me with. Alright, so I'm going to do a couple of examples of founding it. Bounded areas, we mean areas between 2 values. Alright, so the first example, we want to find the area between -1.2 and +1.2. So if I draw the picture for that, alright, remember zero's in the middle, so -1.2. negatives down here, negative 1.2. This would be positive 1.2. All right, the area between is what we're looking for. And so what we want to find, if I draw it with the, using my highlighter, I'm going to kind of draw it out using my highlighter. All right, so the first the z value I'm going to look at is the positive area, which would give me all of this. All right, the table using the positive 1.2 would give me all of that. And then I'm going to look up the negative 1.2. The table negative 1.2 will give me this area. And so if I take the big area, the positive 1, subtract away the little area that comes from the negative 1.2, what I'm going to be left with is the area between, right, which is what I want. All right, so I look up my table value for this. So this is the percent at the z-score 1.2, which comes out to be, if I look at 1.2, the positive 1.2, which is here, that's 88.49%. That would be all of the area less than 1.2. All of the percent less than 1.2. All right, now I look up at the negative score, which will give me this percent at the z-score negative 1.2. So I look at the negative. All right, the negative 1 is 11.51%. I want the difference between the two, and so you take the 88.49% minus the 11.51%, and that leaves me with the exact one that I'm looking for, the one in between, which comes out to be 76.98. 76.98% is the area between those two z-scores. All right, let's do another example. This is the hard one. I'm going to actually do 3 of these. All right, so between two negative values. So if I draw the picture, it's a horrible picture. I'll draw one. Drawing it on a tablet, not always easy. All right, so both of them land to the left. So the negative 0.6 is here, and then negative 1.4 is below it, right, because that's less than it. So this is the area we want. This is the percent we want. And so I'm going to find the big area, which is the area from the table value at negative 0.6, and the little area, which is the area table value from negative 1.4, and when I find the difference, that's the answer I'm looking for. Alright, so I go to my table, which is, again, I'm going to use the one that I have in the notes here, since it's here. Alright, so first, the negative 0.6, which puts me at 27.43, so this is 27.43%, the big area. Negative 1.4 puts me here, that's 8.08%. Can't read that, 8.08%. And so to find the area I want, I take the 27 and subtract away the 8. So to find the area I want, to find the percent I want, which is that red area I've got shaded, I take the 27.43% found at the negative 0.6 z-score, subtract away the 8.08% found at the negative 1.4, and that leaves me with the region that I want, which is 19.35%. Alright, that's the region I'm looking for. The last example. So again, this one, so I did one between a positive and a negative. I did one between two negative values, and so this one's between two positive values. So again, if I draw the picture, it's always a good idea to have the picture so you understand what you're looking for. So they're both positive, means they're both going to land above. So there's the 1.2 and then the 1.7. So the 1.7 is the bigger value. Alright, so there's the area I'm looking for. So I'm going to find the area at 1.7 and then the percent at 1.2, and I want the difference between the two. I should have drawn a little less than it, so actually maybe I'll go here. That's the big area, that's the little area, and I want the difference between the two. Alright, so I look up at the table value at 1.7 is going to give me the bigger number, so 1.7 puts me here, and that is almost all of it, 95.54. So 95.54%. And then 1.2, so I go look at my table, 1.2 is the 88.49. 88.49. And it should be a small area, right? This is going to take away a 98, 95, and I'm going to subtract the 88. So to find this region that I'm looking for, I take the 95.54% minus the 88.49%, and that will leave me with the percent that I'm looking for. And again, it should be fairly small. It comes out to be 7.05%, I believe. 95.54 minus 88.49 comes out to 7.5. I was just double checking. And again, it's a small percent. So again, percent per 20. So that's the tough one. Alright, so again, that's the harder case. Alright, so the next thing I'm going to talk about is sort of the rule of thumb. Alright, so the rule of thumb is that now 68% of all the data values land between 1 and negative 1. Alright, that's one standard deviation. So if I look at my standard normal curve, that's one standard deviation. If you go test this out with the table, so if you go look at the table values at 1, so the table value at 1 and the table value at negative 1. Just kind of using, so remember the rule of thumb is sort of a rounded area, so we'll see when we do it using the table value. So 1 for my table value is 84.13, and negative 1 is 15.87. Alright, so 84.13, and for some reason I can't remember these, 15.87. So 15.87%. So remember to find that area. We take the bigger number minus the little number. So if I take my 84.13 minus my 15.87%, this is more exactly what it would be, but we use the rule of thumb because it's a pretty accurate. Comes out to be 68.28. And so what we do when we use, again, it's a rule of thumb, it's an estimation, and so we estimate it to be the 68%. Alright, the same thing happens with the 95. Alright, it's an estimate. So we find the z-score at 2 and the z-score at negative 2. And so when I look at my table, the z-score at a positive 2 is 97.13, and at negative 2, I have it listed down here, so negative 2 would be at 2.28. 2.28. So again, we take the bigger one minus the smaller one. So we take the 97.13 minus the 2.28. Should be close to 95. 97.13 minus the 2.28 comes out to be 94.85. So again, we'd round that to 95. And we do. When we use the rule of thumb, it is an estimation. It is a rounded estimate. So that's why I said we use it as an estimator. And it's a pretty good estimator. Again, this would be exactly what it is. But what we do is we just basically round it up to the whole number in these cases. So again, this would be the total area there. So only use the rule of thumb when it says use the rule of thumb. When it says use the table because the table is more accurate. So make sure you use the table if the problem says use the table. Otherwise, you could be off a little bit depending on how you round. Alright, working backwards. I'll do that in the next video, so I'll stop there.